Okay, so inverse of matrices part 2. This is example C, and it asks you to find the inverse of the matrix or state that it does not exist. So we just talked about what an inverse was, right? It's the matrix that I can multiply by that will give me back the identity, which was the diagonal of ones. But now we have to figure out how to find it. So up here on the wall, I have the steps in how we're going to find the inverse. First, what you need to find is the determinant. The determinant is just going to be, you're just going to multiply the diagonals. Multiply the diagonals and subtract. So, if I multiply my diagonals here, you want to start reading. When we start reading, we start from the top left, right? Correct. So we want to start with the 6. 6 times 5. This is always the first diagonal. And it does matter the order. So 6 times 5 gives me 30, right? To find the determinant, you always want to subtract the product of the diagonals. So the 6 times 5 gave me 30. And then the 10 times the 3, or the 3 times the 10, also gave me 30. And I always want to subtract. You subtract the products of the diagonal. So 30 minus 30 gives me 0. My determinant is 0. Good to know. Now, the formula for an inverse matrix is going to be 1 over the determinant, and then we are going to switch the main line, switch the first diagonal, keep the second 2 numbers where they are, but make them the opposite sign. And when I multiply this with scalar multiplication, it will give me the inverse. So here's the thing. I didn't leave a lot of space for C1. That is because when I try to put it in the formula to find the inverse, I would have 1 over the determinant, and the determinant is 0, right? I can't have a 0 in the denominator. So whenever the determinant is 0, I don't even have to bother with the rest. The inverse does not exist. That's why they put does not exist is an option. Does not exist is my answer because we cannot divide by 0. Can't do. So does not exist is the answer to C1. Again, that only happens when your determinant is 0, because we cannot have a 0 down here in the denominator. So on to C2. Okay, again, the first thing I need to do is find my determinant. So I want to multiply my first diagonal. 3 times 2 gives me 6. It will always be a minus. Always be a minus. And then if I multiply the second diagonal, 1 times 4 gives me 4. Okay, 6 minus 4 is 2. 2 is an acceptable number, so I can press on. My determinant is 2. Great. So now I'm going to the formula for the inverse. The inverse is going to be 1 over the determinant, and the determinant is 2. And I said I want to switch my main line. So my main line was the 3 and the 2. Your first diagonal, the 3 and the 2. If I switch places, the 2 will come here and the 3 will go there. Y'all understand what I mean by the switch? Just switch positions on the main line. The other 2 numbers stay put. They stay put, but they become the opposite sign. So because my 1 and 4 was originally positive, they are both now going to be negative. And yes, if they were negative to begin with, they would change and become the positive. Okay? Now, I have to multiply. And it's just scalar multiplication, so it shouldn't take too long. I just want to do 1/2 times all these numbers. All right, so 1/2 times 2 is just going to give me 1. 1/2 times -1 is going to give me -1/2. 1/2 times -4 is going to give me -2. And 1/2 times 3 is going to be a 3/2. If ever a fraction can be reduced, I need to do so. All right? So this is your inverse. If this inverse was called A, if the original matrix was called A, the inverse would be denoted with the little -1, just like when we did with functions, when we had, well, cosine and sign and we had the inverse cosine and they all had that -1 as their exponent. Same thing for matrices. All right. You could also write it with decimals. I do not care which way. I think I prefer fractions, but whatever floats your boat. All right. Now we have one more problem. I'm going to do C3. Okay, so C3, the matrix is 2, -1, 5, -5, and I will send you guys these notes. The star will be 8, -5, -4, 3. All right, so one more time. First thing I want to do is find the determinant. So I want to multiply my main line. The first diagonal, 2 times -5 gives me -10. I always have a subtraction, because I am taking the difference of the products of the diagonals. And then I want to multiply my -1 times 5. -1 times 5 is -5. And you know what that's going to do. When I have subtraction and a negative, we already know that's going to turn into a plus, correct? So -10 plus 5 gives me a determinant of -5. And that's fine. There's nothing wrong with the negative number. It just can't be 0. So the formula, which I erased, says 1 over the determinant. So 1 over -5. And I wanted to switch the main line. So the 2 and the -5 are going to switch places. So that'll be a -5 here and a 2 there. The other two numbers stay put, but they become the opposite sign. So my -1 and my 5 stay put, but they're going to become the opposite sign. So this is going to be a plus, and this is going to be a negative. All right? Switch and opposite. It's up there in the cloud. And now it's just scalar multiplication. So -1/5 times -5. That's going to give me a -5 on top of a -5, which is a +1. -1/5 times 1 is -1/5. -1/5 times -5 again is another +1. And -1/5 times 2 is -2/5. Doesn't matter if you put the negative on the top, the bottom, or just out in front. All right, this would be my inverse. Again, I don't have a letter for it, but let's call it an A inverse. And again, if the fractions could be reduced, you would need to do so. All right, start time.